In this video, we will see the problems from exercise 8.4. Before we solve the problems, let's look at some formulae. If vector A is defined as A1 I cap plus A2 j cap plus A3 k cap, and vector B is defined as B1 I cap plus B2 j cap plus B3 k cap, then the vector product of A with B is defined as the determinant of I cap, j cap, k cap, A1, A2, A3, B1, B2, B3. Subsequently, the magnitude of A with B can also be defined as the magnitude of A into magnitude of B into sine theta, where theta is the angle between vector A and vector B. Now let's proceed to solve the problems, and we'll be using these formulae frequently in the questions. Question number 1. Find the magnitude of vector A, vector product with B. It can also be called the cross product if A vector is defined by this and B vector is this. We know by formula the vector A, vector product with B vector, is equal to the determinant I cap, j cap, k cap, and A1, A2, A3 will be 2, 1 and 3, and B1, B2, B3 will be 3, 5 and minus 2. Solving this, first for the I cap, into 1 minus 2, that's minus 2, minus 3 times 5 will be minus 15, minus j cap into 2 times of minus 2 will be minus 4, minus 9, plus k cap into 2 times 5 is 10, minus 3 times 1 is 3. So further solving this, you get minus 17 I cap minus 13 j cap, sorry, it should be plus, minus into minus 13 will be plus, then it's plus 7 k cap. Now the magnitude of A, vector product with B, is equal to square root of minus 17 squared plus 13 squared plus 7 squared, and that's equal to square root of 289 plus 169 plus 49, and that's equal to, adding them up, it comes to root of 507. So that's the required answer. Before we proceed with the second problem, we know that vector product is not commutative, and also A vector product with B is equal to minus of B vector product with A. So we'll be using this in our problem. So let's proceed to solve the problem. We are given A cross product with B plus C plus B cross product with C plus A plus C cross product with A plus B. You can either call them cross product or vector product. Now since they are distributive over the sum sign, so you can say that, or expand this left hand side as A cross product with B plus A cross product with C plus B cross product with C plus B cross product with A plus C cross product with A plus C cross product with B. Okay, now we'll rearrange these three with the minus sign using this non-commutative law property. So this is equal to A vector product with B plus A vector product with C plus B vector product with C, A cross product with B cross product with A will become minus of A cross product with B. So this is minus A cross product with B, and this is minus A cross product with C, and this is minus B cross product with C. Now you can see that our A cross B will be cancelled, A cross C will be cancelled, and B cross C will be cancelled. So you'll be left with 0 vector. So that's our result. Before we proceed with the third problem, if we have two vectors, vector A and vector B, then their is perpendicular to both vector B and to vector A. Alright, so what's given here to us is find the vectors of magnitude 10 root 3 that are perpendicular to the plane which contains these two vectors. So when we draw a vector which is perpendicular to these two vectors, then automatically it will be perpendicular to the plane. So if this is, let's define vector A is equal to I cap plus 2j cap plus k cap, and vector B to be I cap plus 3j cap plus 4k cap. So vector A, vector product with B, will be perpendicular to these two vectors. So that is given by the determinant I cap, j cap, k cap, 1, 2, 1, 1, 3 and 4. A1, A2, A3 here, and B1, B2, B3 here. So that's equal to I cap into 8 minus 3 minus j cap into 1 times 4 is 4 minus 1 plus k cap into 3 minus 2, which is equal to 5 I cap minus 3 j cap plus k cap. Now we can say that this vector, which is the vector product A cross product with B, is perpendicular to both of this. So we are asked to find, if we find an unit vector here which is n cap, then that n cap will be defined as, or I can say that the unit vector perpendicular to A and B is defined as n cap is equal to A vector product with B divided by the magnitude of A plus B vector, and it's a plus or a minus here. It can be in this direction or it can be in the opposite direction. So we already found A cross product with B. So the magnitude of A cross product with B is equal to the square root of 5 squared, which is 25, plus minus 3 squared, which is 9, plus 1 squared, which is 1. So that's equal to root of 35. So our n cap is defined as plus or minus 5 I cap minus 3 j cap plus k cap divided by square root of 35. So further we can say, if we multiply n cap with this 10 root 3 magnitude vector, or sorry, scalar quantity, so this becomes 10 root 3 n cap is equal to plus or minus 10 root 3 into 5 I cap minus 3 j cap plus k cap divided by square root of 35. So that's our required answer. Question number 4. Find the unit vectors perpendicular to each of the vectors a plus b and a minus b. You're given vector a as this and vector b as this. So to find the unit vector which is perpendicular to this and this, we need to find the vector product of these two vectors. Once you find the vector product of these two, and then you will have the perpendicular vector, then it's easy to find the unit vector from there. So let's define our C as equal to vector A plus vector B, which will be A plus B will be 2i cap plus 3j cap plus 4k cap. And let's define D vector as A minus B vector, and that will be equal to 1 minus 1 will be 0i cap. So 1 minus 2 will be minus j cap. 1 minus 3 will be minus 2k cap. So vector C, vector product with D vector will be equal to the determinant I cap, j cap, k cap. And now the coefficients of I cap, j cap, k cap for vector C is 2, 3 and 4. So 2, 3 and 4. Similarly for vector D, it is 0, minus 1, minus 2, minus 2. So solving this determinant, I cap into minus 6 plus 4 minus j cap into minus 4 minus 0 plus k cap into minus 2 minus 0. So your answer is minus 2i cap, and this will be a plus 4j cap and minus 2k cap. So the vector n cap, which is the unit vector perpendicular to C and D, which is n cap, defined as n cap, is equal to plus or minus C vector product with D divided by the magnitude of C vector product with D, and that is equal to our C vector product with D is minus 2i cap plus 4j cap minus 2k cap divided by the square root of 2 squared is 4 plus 16 plus 4, which is equal to minus 2i cap plus 4j cap minus 2k cap divided by square root of 24. You have to incorporate the plus or minus here, plus or minus here. So this can be further simplified as plus or minus minus 2i cap plus 4j cap minus 2k cap divided by 24 can be expanded as 4 into 6. So you can call this as 2 times root 6. Further, eliminating 2 from the numerator, you can define this as plus or minus I cap minus 2j cap plus k cap divided by root of 6. That's the required answer. Before we solve this problem, let's recollect some of our identities. Now, if this is vector A and vector B, and this is our vector cross product or vector product with B, then the magnitude of this vector product with B can be defined as the area of the parallelogram A with A and B as its adjacent sides. So that's the magnitude of A. You can call it as the area of the parallelogram with vector A and B as adjacent sides. Okay, it's just for our reference. So now let's start to solve the problem. Let's define vector A as I cap plus 2j cap plus 3k cap and vector B as 3I cap minus 2j cap plus k cap. So A vector product with B is equal to the determinant of I cap, j cap, k cap, 1, 2, 3, 3 minus 2 and 1, which is equal to I cap into 2 plus 6 plus minus j cap into 1 minus 9 plus k cap into minus 2 minus 6. So that's equal to 8 I cap plus 8 j cap minus 8 k cap. Therefore, the magnitude of A vector product with B is equal to square root of 8 squared plus 8 squared plus minus 8 squared, which is equal to square root of 3 times 8 squared, which is equal to 8 into root 3. Therefore, the area of the parallelogram is equal to 8 root 3 units. Question number 6. Find the area of the triangle whose vertices are given by these points. Before we do that, we have seen in the previous problem that if you are given two vectors A and B, then the area of the parallelogram is the magnitude of A cross product with B. Now, if I am going to divide this parallelogram into two equal halves, then you have a triangle here. Then area of the triangle with sides A and B is equal to half the magnitude of A vector product with B. So we'll be using the same formula for this. So here we given 3 points, so we need to find their position vectors first. So let's define vector OA as 3I cap minus j cap plus 2k cap, and OB vector as I cap minus j cap minus 3k cap, and OC vector as 4I cap minus 3j cap plus k cap. Area of the triangle ABC can be defined as half of magnitude of AB vector product with AC, or it can also be found by using vector BA cross product with BC, or you can do half of CA vector into CB vector. Any two sides can be taken, and if you find the cross product or the vector product and find the magnitude and divide it by half, then you will find the area of the triangle. So let's do AB cross product with AC and let's get the area of the triangle. Vector AB is equal to OB vector minus OA vector. which is equal to, or OB vector is I cap minus j cap minus 3 cap k cap minus 3 I cap plus j cap minus 2 k cap. So that's equal to minus 2 I cap, j cap will become 0, minus 3, so minus 5 k cap. Similarly, our vector AC is equal to OC vector minus OA vector. Our OC vector is 4 I cap minus 3 j cap plus k cap minus 3 I cap plus j cap minus 2 k cap. That's equal to 4 minus 3 is 1 I cap minus 3 plus 1 minus 2 j cap plus minus 2, so it's minus k cap. So vector AB, vector product with AC is equal to I cap, j cap, k cap, and AB vector coefficients are minus 2, 0 and minus 5, and AC vector is 1, minus 2, minus 1. So solving this, we get I cap into 0 plus, minus 10 minus j cap into 2 plus 5 plus k cap into 4 minus 0. That's equal to minus 10 I cap minus 7 j cap plus 4 k cap. So the magnitude of A vector product with AC, AB with AC, would be equal to the square root of minus 10 squared plus minus 7 squared plus 4 squared. That's equal to root of 100 plus 49 plus 16, which equals to square root of 165. So the area of triangle ABC is equal to half the magnitude of A vector product with AC. So that's equal to half of square root of 165. That's, you can rewrite it as square root of 165 divided by 2 square units. Question number 7. If A, B, C are position vectors of the vertices A, B, C of a triangle ABC, show that the area of the triangle ABC is half of, given by this. Also deduce the condition for collinearity of the points A, B and C. So what is given to us is vector A is equal to the OA position vector, and vector B is OB vector, and vector C is OC vector. Now the area of the triangle ABC is equal to half of magnitude of AB into AC vector. So further we can deduce from this, our AB vector is equal to B vector minus A vector, and our AC vector is equal to C vector minus A vector. So substituting those values here onto this formula of the area of the triangle, half of, so your AB vector is B vector minus A vector, and your AC vector is C minus A vector. So further expanding them, cross product here, further expanding them, you get B cross product with C minus B cross product with A minus A cross product with C plus A cross product with A magnitude. So further expanding this, rather simplifying it, this will become plus A cross B, and this will become plus C cross A, and this will be 0. A cross product with A will be 0. So you will get this is equal to half of B vector cross product with C plus A vector cross product with B plus A vector C vector cross product with A, which is our right hand side. So hence the first part of the equation is proved. Now for collinearity, we have to show that the area of the triangle is equal to 0 because they all fall on the same straight line. So if A, B, C are collinear, then the area of the triangle ABC is equal to 0. Therefore, half of our B vector product with C plus A vector product with B plus C vector product with A is equal to 0. So further simplifying this, we can say by taking the 2 to the other side and further opening up the magnitude, we can say that A cross product with B plus B cross product with C plus C cross product with A is equal to 0 is the required condition of collinearity of the points with position vectors A, B and C.
Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.